What's up, everybody? Welcome back to another live stream from Scalar Learning. Today we are continuing this series on the online math program called ALEKS, which is now owned by McGraw-Hill. It's a great online math curriculum program, as I've stated many times. Let me just do a quick sound check. Make sure we're doing good here. You guys can hear me. Yep. All right, we are good. So we're talking about ALEKS, and ALEKS is great. We use it at our school to supplement the math curriculum. And what I'm doing in particular, since I teach 6th grade and I work with so many students who are studying pre-algebra, I'm going through the pre-algebra pie. And what will exist at the end of this journey is 630. You see there's 630 topics. What will exist at the end is 630 individual video explanations per topic. So far, I've completed about 143 topics, so there's 143, exactly 143. So there's 143 explanation videos, most of which are already uploaded onto my YouTube channel. So you can check those out in the various categories. But anyways, the goal was to finish it by Sunday. I don't think that's necessarily realistic at this point, since I'm only about a quarter of the way through. I'm going to try my hardest to do that. The issue that I'm running into is that ALEKS seems to slow down after I complete about 10 or 15 topics per session. So that makes it difficult. I'm going to try something today. I'm going to go as fast as I can for as long as I can. And once it starts to glitch, I'm going to log out and then try logging back in. I'm going to see if that remedies the issue. All right. Without further ado, let's jump into ALEKS. All right, first topic here, absolute value. When we talk about absolute value, I think of it as a positive purifier. Whatever is in there comes out positive. So these are the absolute value bars. You can also think about absolute value as measuring the distance, of a value from 0. And remember, distance is always positive. So absolute value of 11 is the distance from 11 to 0, which is 11. The absolute value of 11 is indeed 11. The other way to think about it is, hey, it's the positive version of this number. Since 11 is already positive, absolute value of 11 is positive 11. Absolute value of 10, negative 10, well, it's a positive purifier. What comes out is positive 10. And there we go. So our two answers are 11 and 10. Now let's talk about these two. Again, we have absolute value of 10. Absolute value of a positive number is just the number itself. Absolute value of that negative 9 is positive 9. And this one is going to be positive 12, and of course, just 8, positive 8. Topic 1 and done. Next topic. Converting a fraction with a denominator of 100 to a percentage. All right, these are great. Now the key with this is, as a percentage, it's important to know, what does percent mean? Percent is a French word, and it literally means per 100. Cent means 100. So if we say something like 25%, that's 25 per 100, or 25 out of 100. Well, now we're going the other way. We're starting with 5 out of 100, or 5 per 100, which is really 5%. So anytime you have a number like this over 100 and you want to convert it to a percent, well, it's technically already there. You just take the 5 down and write it as 5%. This is equivalent to saying it's 5 over 100. So we say 5%. The next two will go pretty quickly. This is just 68%. And of course, this last one is 9%. Oops. Introduction to converting a percentage to a decimal. 48% as a decimal. Now, when we convert percentages to decimal, think about this acronym. Think about down for the party, DFP. D stands for decimal, F stands for fraction, P stands for percent. But the main ones that are important are D and P. So if we have a percentage, right, and we're trying to convert it to a decimal, we're right here. 48%. And there's an invisible decimal point right here. To go from P to D, we have to move once, twice to the left. So the same thing, to turn a percentage to a decimal, we have to go once, twice to the left. And the decimal equivalent of 48% is 0.48. The other way to remember this is now 48/100ths. Remember I said 48 out of 100 is really 48%. So that makes sense that this would be equivalent to 48%. All right. Oh, they wanted a 0 in front. And then same thing here. 8%. We move that decimal spot over once, twice, fill it in with a 0. And our decimal is 0.08. Last one, 50%. We go once, twice. Make sure to have a leading 0. And we've got 0.5. We don't even need the 0 afterwards. Identifying, what is this? Oops. Identifying, I can't read it. Okay, let's just see. Identifying relative change when combined with something. Okay, well, let's just check this topic out. For each scenario, choose the best statement. A boxer loses 3 pounds and then gains 3 pounds. So the boxer is above his starting weight? No, because if you lose 3 pounds and then gain 3 pounds, you're back to where you were. So we're talking about, is this a net positive change, negative change, or net 0 change? Think about it. If you go down by 3 pounds and then up by 3 pounds, is the equivalent of a negative 3 combined with a positive 3, which is 0. So the boxer is 0 pounds from his starting weight, meaning he's right back where he started. A roller coaster goes up 30 feet and then down 30 feet. Where are we at? We're again at 0, so there's no change. The roller coaster is at its initial height. You spend $18, so we're losing 18, and then you are paid nothing. So we're at negative 18. We're at a negative value, which means you have less money than you started with because we've lost money. Let's go on to the next one here. A football team gains 5 yards, positive 5, and then loses 2 yards. We have a net positive change of positive 3. So the team must be ahead of its original position. A bird flies down 20 feet and then up 20 feet. Net positive change of 0, meaning the bird is 0 feet from its initial height. It's still at the initial height. And last, the price of a stock increases by 17 and then decreases by 17. Net change of 0. Stock's price is the same as it started. Last one, a roller coaster goes up 10 feet, positive 10, and then down 20 feet. We are at a net loss of 10 feet or negative 10. So the roller coaster is below its initial height. The temperature drops 6 degrees and then rises 9 degrees. Negative 6 plus 9 is positive 3. So it's higher than its original value. And the company loses 16 employees and then gains 16 employees with the net change of 0, meaning the overall change in the company's size is 0. All right, next problem. Exponents and integers, problem type 1. Cool, so now this is really important with these guys. So negative 5 squared, why are these parentheses here? These parentheses are very important. If these parentheses weren't there, like for example, if it was just this, we would be squaring the 5, not the negative 5. So it would be 5 squared, which would be 25, and then the negative would be right there. And it'd still be a negative answer. But this is different. This means we're squaring that negative value included within the 5. Which means it's actually negative 5 times negative 5. Remember, what happens when we do a negative times a negative? They cancel out. It becomes a positive. So this becomes a positive 25. And then what about this one down here, a negative 8 cubed? This is that entire quantity, negative 8 times negative 8 times negative 8. So 3 times. So we got a negative times a negative, which becomes a positive. But then there's another negative in the mix, which will turn everything back to a negative. Now we just have to do the arithmetic. So what's 8 times 8 is 64 times 8 again. 48 is 51, 512. So the answer is negative 512. Next one is 4 cubed and negative 3 to the 4th. So this one again is 4 times 4 times 4, which is actually 64 if you carry out the multiplication. 4 times 4 is 16, times 4 is 64. This is going to be 4 negative 3 is. Now, the first question is this going to be positive or negative? When we have an even number of negatives multiplying, the answer is going to be positive. The negatives will cancel each other out. And we can do it step by step if you want. This will first become positive. Then this will turn it back to negative, this guy. And then this one will turn it back to positive. So we're going to have a positive number. And what's that number? 3 times 3 is 9. Times 3 again is 27. Times 3 again is 81. So positive 81. Let's do this last one here. This is negative 8. It's negative 8 times negative 8. The two negatives cancel out and give us a positive 64. And down here we got a negative 6 cubed, which means we got 3 negative 6s multiplying each other. And that equals a positive, but then that last negative makes the final answer negative. And what's 6 times 6 times 6? 6 times 6 is 36, times 6 again is 216, but our answer is negative 216. All right, cool. Next question, translating a sentence by using an inequality. Okay, so this is how I'm going to step through this. Y is greater than or equal to 8. So first of all, the greater than or equal, well, let's put down the Y. I'm just going to go Y. And it's got some relationship to 8 in that it is greater than or equal to. The greater than symbol goes that way. The mouth is opening that piece. So if I say Y is greater than something, the alligator mouth is going towards Y. So Y is greater than, if it was just greater than 8, it'd be greater than 8. But it says greater than or equal to. To signify the equal to, we put a little line underneath it. Now it can be greater than or equal to. What does that mean? If it were just greater than 8, it means it couldn't equal 8. It could be anything above 8. It could be 8.1, 8.01, etc. Just not 8 exactly. This means it can be 8 as well as anything above 8. So we would write it Y is greater than 8. This, by the way, is the same as if I could also write it like this. This would also be correct. It just, as long as that open mouth is facing the Y. Nine is less than or equal to X. 9 is, now if it were greater than, again, this is in reference to the 9, it would be going this way, but it doesn't say that. It says 9 is less than or equal to X. So we put 9 less than or equal to X. And then 1 is greater, so 1 is greater, so the alligator mouth eats the 1, greater than B. Doesn't say or equal to, so no line underneath, so we say 1 is greater than B. Introduction to angle addition. All right, so it says the measure of FGH right here is 75. The measure of angle, this guy is 25. And we need to find X. Okay. So it might look deceiving because this looks like it's drawn a longer line, but look, this line is the same as X plus 25. Even though these lines look smaller, that angle distance is equivalent. So it's just kind of coming further. Like I could have written X out here and it'd be the same value. So it's not that exact distance. It's this measure of this angle down here. So what are we really saying? We're really saying that 25 and X are the parts that when added up equals 75. So this is the same as saying 25 plus X equals 75. Therefore, to solve for X, we could subtract 25 from both sides. And we see that X equals 75 minus 25, which is 50. All right, same deal here. We need to find the angle of X. So again, x plus 80 equals 120. X plus 80 equals 120. So let's solve for x. We're going to subtract 80 from both sides with a good variable isolation. And x equals 120 minus 80, which is 40 degrees. Okay, now this is a little different. Now we're trying to find that total value. So what can we say here? Well, now we can say that these two parts add up to equal x. So in this case, they're saying that 25 is one part plus 35 is the other part equals the total, which is x. So now we just got an addition problem. What's 25 plus 35? It's 60. 60 equals x. Okay, let's keep going. Identify the parallel, perpendicular, or neither. Okay. First of all, let's talk about what are these definitions. Parallel lines are two lines. Oops, that's not the greatest parallel. Kind of like this. The two lines that are exactly lined up. We see parallel lines all the time, and we can see even these little grid lines here are all parallel. What it really means is these lines, if they go on and on forever and ever in both directions, it means that they'll never intersect. Okay, it's like two railroad tracks. They'll never come into contact with each other. That's perfectly parallel. Perpendicular lines is like this. It forms a perfect L shape, okay, or a perfect T, perfect cross. And these form a 90-degree angle in here. We can denote that with these little boxes. And that's that. So lines can either be perpendicular or parallel or neither. Neither is anything in between, where they since parallel don't cross, neither means they have to cross. They're just not crossing at 90-degree, perfect 90-degree angles. So if we look over here, these two are parallel. They're perfectly lined up. These two are perpendicular. It's hard to tell because they're diagonal, but they are forming, if we kind of rotated this, we'd see that this is a perfect T shape right here. So that's perpendicular. These guys are also parallel. Looks like they will never hit each other. And then these are neither. These are not, definitely not parallel and definitely not perpendicular. These guys, they don't intersect, but they are going to intersect if this continued down, because these are lines that continue forever. So these are neither. These will intersect as well if we continue this on here. Neither. These will likely never intersect, so they are parallel, and these are nice. The nice T shape makes them perpendicular. Again, neither perpendicular forms that perfect 90-degree angle. Neither, not parallel and not perpendicular, and these are parallel. Writing a sign number for a real world situation. They withdrew $80 from his checking account. So what does that mean? Is that a positive or negative change? It's kind of funny because it depends on whose perspective you're looking at, right? If you're looking at the person who is Trey, or sorry, if you, well, I guess yeah, it's kind of weird, right? Like he's getting $80 in his hand. But the idea is that his bank account is, oh yeah, it says that actually, change in his account. So the account, while he's getting money, the account's losing money. So anytime you're seeing a loss, it's a negative. Nicole's test score average increase. Anytime we're talking about an increase, we're talking about a positive 7. Now you don't have to write plus 7. You can just write 7. All right, there we go. Let's go to the next one. The elevation of a point is 149 feet below sea level. So this is represent the elevation. So this is below something. Some reference points will say negative. Temperature fell by 4 degrees, went down. It reduced, again, a negative sign. Last but not least, dive to a point 640 feet below sea level. Let's use a negative there. Temperature rose. If it goes up, that's a positive change. Okay, cool. Next question. Introduction to properties of addition. Okay, so first of all, let me explain associative, commutative, and identity. This one is, first of all, let's fill in the numbers. So we're trying to make true statements. 6 plus 7 equals what plus 6? It's got to be 7. 8 plus 5 plus 3 in parentheses like this has to equal also an 8 plus 5 plus 3. Now this one is obvious. This one, if we actually carried out the arithmetic, 8 plus 5, if we do that first, is 13. Then plus 3 is 16. And on the other side, it's got to be 8 plus 5 plus 3. 5 plus 3 we do first, which is 8. And this has got to be an 8 to give us 16 to make these equal statements. And then 3 plus what equals 3? It's got to be 0. Okay. Now I'm going to explain what the properties are that are associated with this. So this is called an example of the commutative property. The commutative property states that the ordering, when you have a commutative property of addition states that when you have just addition happening, the ordering of the numbers has no impact on the final answer, which means 2 plus 8 equals 8 plus 2. 9 plus 10 equals 10 plus 9. 6 plus 7 equals 7 plus 6. So this is an expression of the commutative property. This is an expression of the associative property. The associative property states that the use of parentheses when we're only dealing with addition has no impact on the final answer. So even when they've grouped 8 and 5 here, and here they group 5 and 3 together first, and the parentheses again dictate what we do first, it has no impact. So as I showed you here, we get 16 both ways. That is called the associative property. You should always think associative when you see parentheses being moved around. Last but not least, we've got 3 plus 0 equals 3. This is called the identity property. The identity property states that if you add 0 to any number, you're just going to get that same number. So 5 plus 0 is 5, 10 plus 0 is 10, 3 plus 0 is 3. So as stated before, we're going to go through this again. 9 plus 2 obviously equals 2 plus 9. 2 plus 6 plus what equals 2 plus 6 plus 9. This is also going to be a 9. It's going to be the same numbers on both sides. And here we've got a 9 plus 0 equals 9. So when we've moved around the order, it's again commutative property. It's an expression of the commutative property. When we've manipulated the parentheses and left everything else the same, it's the associative property. And here, again, any number plus 0 is itself. That is the identity property. All right, let's fill these guys in. So this is a 5 here. This has got to be 0 plus 7 equals 7, and this has got to be 6. So this is, again, an expression of the associative property because we've moved parentheses around and left everything else the same. This is called the identity again. 0 plus any number is itself, and this is commutative, where the order has no impact. Okay, let's keep going. Constructing a line plot. Draw a line plot for these numbers. So what are we trying to do? We're trying to basically count up the number of each one of these numbers and plot them out. So let's first count the number of 9s. We got 1 and we got 2 9s. All right, so that means we put 1, 2, X is above the 9. It's like a bar graph. And now how many 8s do we have? I'm just going by 8s because that's the next one I see. I got 1 8, 2 8, 3 8s, 4 8s, 5 8s. So we go 1, 2, 3, 4, 5. I see a 7 and I've only got 1 7 in the mix. I've only got 1 3 in the mix and everything else has been accounted for last. Let's count these numbers up again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just as a way to double check, do I have 9 X's here? 2, 7, 8, 9. Yeah. So I'm pretty sure we did this correctly. Let's go for it. Next problem. Let's do it again, same way. So how many 9s do we have? We have 1, 2, 3, 3 9s. 1, 2, 3. How many 8s do we have? 1, 2, 1, 2. How many 6s we got? We got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 7s, we got 1, 7. Last but not least, nines. We got 1 9 that I see. We've got 1 7, 2 7s, 3 7s. 1, 2, 3. We've got 1 6 only. We've got 1 8, 2 8s, 3 8s, 4 8s. 1, 2, 3, 4. And we got 1 lonesome 1. Everything else has been accounted for. Let's double check our work again. We got 5. We got 10 numbers. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers here. Yeah. Okay. Identifying a sum as a point located on a number, located a given, what is this? As a point located a given distance from another point. Okay. Here we go. The number -4 is plotted on the number line below. Answer the following questions. Which is a point 7 units to the right of -4? So if we're going 7 units to the right, anytime we're moving into the right, we're adding a positive number. So that means whatever it would be, if we did go 7 to the right, we're going 1, 2, 3, 4, 5, 6, 7. We're getting right here, which is +3. But effectively, all we're doing is we're adding 7 to the stationary point. So where is -4 plus 7? Right here. This is wrong because that would be going to the left by 7. This is wrong because it's the wrong starting point, and same as this, and it's the wrong movement. Which is a point 7 units to the left of -4? Well, again, if we're going to the left, now we'd add a -7, or we'd subtract 7, same thing. So we start with a -4 plus -7 right there. The number 5 is plotted on the number line below right here. Answer the following questions. Which is a point 1 unit to the left of 5? So if we're going 1 unit to the left, we're adding a -1. Which is a point 1 unit to the right of 5? We're adding a +1. So now let's look here. So where do we see 5 plus -1? Right there. Where do we see 5 plus 1? Right here. That's that. Okay, last one, the number -3, which is a point 6 units to the left of -3. Again, to the left means we're adding a -6 units. This one is 6 units to the right. That's a -3 plus +6. So -3 plus -6 is right here. Whoops. -3 plus +6 is right there. Next question. Division of a decimal by 1-digit decimal. Let's see the full name of this. Problem type 1. Okay. Now, this is a new element that we haven't dealt with yet. So we have 6.51 divided by 0.3. But there's a general rule when we do division. We don't want any decimals in the divisor. We remedy that by just moving the decimal over until there's no decimals left. But we can't just do it to the divisor. Whatever we do here, we have to do to the dividend. So we're going to do the same movement here. And the new decimal point comes here. And this is very important because that means the decimal point in the answer comes here now, not here. And now we just do the division as regular. 3 goes into 6 twice. 2 times 3 is 6. Subtract, we get 0. Bring down a 5. 3 goes into 5 once. Multiply. Subtract, 5 minus 3 is 2. And then bring down the 1. 3 goes into 21 7 times. 7 times 3 is 21. And we get a remainder of 0. But our answer is 21.7. Next question. 34.2 divided by 0.09. How do we get rid of all the decimals here? We got 2 decimal places, so we got to go once, twice. But what about this one? Well, same thing. We go once, twice. What goes in this empty spot? A 0, of course. And now let's do the division. Just like we were dividing, it's like 3,420 divided by 9. That's all it is. So 9 goes into 34 3 times. 3 times 9 is 27. 34 minus 27 is 7. Bring down the 2. 9 goes into 72 8 times. 8 times 9 is 72. Bring down the 0. And 9 goes into 0 0 times. Right? The decimal would be up there, but we've got no remainder. And we're done right at this point. So the final answer is 380. All right, last problem here. 9.57 divided by 0.03. Same dealio. Let's move this guy once, twice. Let's move this guy same amount once, twice. Put that decimal right up top. And let's do the division. 3 goes into 9 3 times. 3 times 3 is 9. Subtract. Bring down the 5. 3 goes into 5 once. Multiply by 1. 5 minus 3 is 2. And then bring down the 7. 3 goes into 27 9 times. 9 times 3 is 27. And we're done. No remainder. The answer is 319. All right, let's continue. Introduction to factoring with numbers. Use the distributive property to fill in the blanks below. Okay, so what's going on here? We've got 5 times 7 plus 5 times 8. When we're factoring, what we're doing is we're looking at these two quantities. They're being added together, and we're looking to see what's common out of both of them. Factoring is really just division. So it's like, what's common between these two? Well, we have a 5 and a 5. So what we can do is I can divide both of these expressions by 5. Not just like this necessarily. I mean, technically yes, but instead of doing that, we're literally taking these 5s and yanking them out. You can only do this if there's a 5 in both. So we're yanking the 5 out of both of these. And we're putting it up here. That goes away and that goes away. So if we do that, now we've got a 5. And we've still got this expression that we're adding up. But we've pulled the 5s out of each of these pieces. And so what's left is now just the 7 and just the 8. And this is what's called factoring. So when we pull that out, we've got a 7 and we got an 8. Why are we doing this? Well, because they're equivalent expressions, and this is the introduction to an operation that's super important when you move on to more advanced algebra, is the ability to factor and distribute, especially when you have variables inside. Now let me prove that this is indeed the same. So I'm going to first start with the original expression, and I'm going to carry it out. So 5 times 7 is 35. 5 times 8 is 40. Then if we were to add them up using standard PEMDAS, 35 plus 40 is 75, which I'm telling you is the same as this. So let's do it this way. I factored out a 5. Now PEMDAS says that we would add 7 plus 8 together and get 15. These are the same parentheses. These are just brackets. They're the same thing. And then now we have the 5 times 15. 5 times 15 is indeed 75. And that's what factoring is all about. Whoops. Next one, we've got 4 times 3 plus 4 times 2, same thing. What's common in both of these expressions? The 4. So we're going to pull the 4 out of both of these guys. And then what's left is a 3 and a 2. So now we've got 4 times 3 plus 2. And that's all we're doing. So here the 4 comes out there. Last one. This is repetition. I'm going to blaze through it. Again, just pulled out the common number. Introduction to identifying solutions to an inequality. For each value of y, determine whether it is a solution to y is less than 9. So what does this mean, by the way? Well, this means that y can be any value less than 9. Not 9, it can be any value less than 9. So that's how we'd represent it on a number line, which means it could be 8. All the shaded part represents is what it can be. It could be 7, it could be negative 100. It can be anything that's less than 9. So now let's look at these answers. But it cannot be 9 because it says it's less than 9. So is 9 a solution? No. Is 13 a solution? No, 13's over here. It's not part of my solution set. What about 6? Yes. Right? 6 is right here. And what about 8? Yeah, 8's included. 8 is less than 9. All right, next one. It says 8 is greater than or equal to v. But you know the way I like to think about this? Not that 8 is greater than or equal to v, that v is less than or equal to 8. And I'll even write it like this. It doesn't matter which one goes on each side. It just matters the orientation of this inequality. So v is less than or equal to 8. So now I know that v is anything less than 8. But because of this equal sign, it can also be 8. So let's look at everything that's smaller than 8. No, that's bigger than 8. No, that's bigger than 8. Yes, that's smaller than 8. No, that's bigger than 8. That's it. Okay, last problem. U is greater than or equal to 13. So once again, you can be anything bigger than 13, and it can also be 13. 15, yes, because it's bigger than 13. 13, yes, that's all right. 16 is larger, that's okay. 7, no, that's smaller, that doesn't work. All right, writing an improper fraction as a mixed number. 14 over 5. So how do we do this? The way we do this is we think about how many times does 5 go into 14. After all, this is just a division problem. It's the same as doing this. So how many times does 5 go into 14? It goes in 2 times. 2 times 5 is 10. And then we have a remainder of 4. So what does this have to do with anything? Well, this is how we convert it into a mixed number. That 2 is the whole number. And then that 4 is what stays in the fraction zone. And the denominator is just what the denominator was at the beginning, or in this case, what the divisor was. That's how you convert a mixed number. The other way is you think about it, you can pull, how many 5s can you pull out of 14? You can pull 1 and 2, which is a total of 10. So that's where we get the 2 from. And then when we pull 10 out, we've got 4 left, which is what we've got up here. So that's another shortcut. You don't have to do long division every time. You can shortcut it that way. So this becomes 2 4/5. Okay, next one. Rewrite 16 over 7 as a mixed number. How many 7s can we pull out of 16? We can pull out 1 and 2, which is 14. So we can pull 14 out. 14 out of 16, what's left? Well, we've got 2 left. 2 out of what? That original fraction. Our original denominator, 7. So this is 2, oops. 2 and 2 7ths. Last one, 31 over 9. How many 9s can we pull out of 31? Maybe a little tougher. We can pull 3 out, right? Because 3 times 9 is 27. So we can pull out 3, which is pulling 27 out of 31, leaving 4. So it's 3 and 4/9. Again, if we wanted to do the division, it'd be 31 divided by 9. 9 goes into 31, like I said, 3 times. 3 times 9 is 27. With a remainder of 4, which means the mixed number is 3 with a remainder 4 over this divisor of 9. All right, cool. All right, word problem with division of a decimal. Let's just make sure, what is this? With the decimal and a whole number. A store owner has 31.2 pounds of candy. If she splits the candy equally into 6 boxes, how many pounds of candy will each box contain? What are they asking? Well, we know this is a division problem from the title of the category. But we've got 31.2 split up into 6 boxes, meaning we're dividing by 6. And now let's just do the division. But remember, when we're dividing and we've got a decimal dividend, we got to make sure first things first to put that dot straight up top, right above the decimal down here. And now let's just do regular division. 6 goes into 31 5 times. 5 times 6 is 30. Do the subtraction and we get 1. Bring down the 2. 6 goes into 12 2 times. And we are done. So the answer is 5.2. I don't even have to worry about the decimal because I've lined everything up. I already put it up there, so there's no confusion. I'm not going to accidentally put 52. All right, now we've got $4.80 for 6 pounds of sugar. How much does she pay for each pound of sugar? So we want to know the price per pound. Whatever comes after the per, that's what we're dividing by. So we take the price per pound and we divide that price by 6. Before I do anything, I'm going to take that decimal, boom, plot it right on top. And now let's do our division. 6 goes into 48 8 times, right? I'm putting it over the last digit of the number we're dividing, 48. 8 times 6 is 48. And that's remainder of 0. And we're technically done. So we could just say 0.8. But the convention is with money that we want to have a 100th spot here. And since we're done dividing, we would just put a 0 there. If you want to try, you can bring the 0 down. It's the same thing. How many times does 6 go into 0? 0 times. It's the same idea. But we're done here. All you got to do is add a 0. And you're good. Okay, last question. The total price for 6 movie tickets is $71.40. If each ticket costs the same amount, how much does one movie ticket cost? We want the price per ticket. So we're dividing the price by the number of tickets. 71.4 divided by 6. We're going to put that dot straight up top, and let's do the division. 6 goes into 7 once. 1 times 6 is 6. Subtract is 1. Bring down the 1. 6 goes into 11 once. Multiply, we got 6. Subtract, we got 5. Bring down the 4. 6 goes into 54 9 times. 9 times 6 is 54. And we're done. But since we got a 0 here and we're done with the division, just add a 0 for good measure. And the price is $11.90. Awesome. All right, so we can, I don't know if you can tell, but I can feel like ALEKS is already starting to slow down. I'm going to try something here. I'm going to log out and log back in and see if that fixes the issue. So we're interpreting a line graph. I mean, you see it's just really taking so long to think. So let's log out. Now let's log back in. All right, let's see if this worked. Area of, I think it worked. Now we can do a longer live stream. All right, so we went to a different topic, but that's fine. Find the area of the shaded figure. Now we're talking about area. What is area? It's represented in square units. Now look what they put this little graph here, and they're like, this is 1 unit, this is 1 unit. 1 square unit is literally a square that measures 1 unit around all the way. So one of these little squares is literally 1 square unit. So what is the measure of this guy? Well, how many square units are inside? 1, 2, 3, 4, 5, 6, 7, 8, 9. But there's another way to tackle this problem if you wanted. The other way to do it is you look at the length of each side, which is, it's 1, 2, 3 singular units. This same side here is also 3 units. Another shortcut to getting that answer is you multiply the length of each side 3 by 3, and you get the same answer, 9 square units. What about this guy? Same thing. We can count them up. We can say 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or we could multiply the length here, which is 4, by the length here, which is 4, which will also get us 16. Last but not least, let's count them up. We got 1, 2, 3, 4, 5, 6, 7, 8. Or again, 2 times 4, which would give us 8. Next, converting a fraction to a percent with a denominator of 100. Okay. No need to simplify your answers. This is very important. Now remember we said in an earlier topic that 5% is the same as 5%, 5 per 100. So to convert it to a fraction, it's literally 5 per 100 or out of 100. So these are pretty straightforward. This is just 5 over 100. Next, 94% is simply 94 out of 100. And last, 1% is simply 1 out of 100. Whoops. All right, finding the area of a composite figure on, what does it say? On a grid. Cool. So this is not as easy. We don't have that nice convention where we can count these sides and this side and multiply because it's a weird shape. But instead, we just count the number of squares, little squares inside. So we got 3, 6, 9, 12, 15, 16, 17. So I got 17 little squares, 17 square units. All right, next we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And last but not least, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Cool. All right, write 1/10 as a percentage. Okay. Now, how do we convert a fraction to a percentage? And let's see what is the exact topic. Yeah, okay. So there's 2 ways to do this, but this is specifically with certain denominators. So the easiest thing to do with these special denominators with 10, 4, 5, or whatever is to get this denominator to 100. So how do we do that? Well, we have to do it with multiplication. What times 10 is 100? 10. But whatever we do to the bottom, we have to do to the top. So why do we do this? Because then we get a number per 100 or a number out of 100. And then that's an easy conversion to a percentage because this essentially is the same as a percentage. It's just simply 10%. 10 per 100 is 10%. Next one, we got 3 out of 5. So same deal. If we get the denominator to 100, we're good to go. 5 times what is 100? 5 times 20. So we multiply the top by 20 as well. And we get 100 in the bottom. We get 3 times 20 is 60 on top, which is the same as 60%. Cool. Last but not least, 2 out of 4. You might represent this as a recognize that this is a half, but if you don't, same deal. How do we get 4 to 100 multiplied by 25? How do we get, then we have to multiply the top by 25, and we get 50 over 100, which again, 50 per 100 is 50%. All right, here we go. Interpreting a line graph. The graph below shows the number of wins by a basketball team over 6 years. So this is in 2012, 2013, 14, 15, 16, and 17. What was the greatest number of wins in the year? That would simply correspond with the highest point up here, which looks like happened in 2017. And how many wins do they have? Well, let's look on the y-axis. That corresponds with, that's not 43, right? That could be tricky, but you got to read this graph and really recognize that, wait a minute, there's a gap of 4 between these two mark points, meaning this is right in the middle. So each one of these intervals is 2. So therefore this would be 44 and then 46, right? Just like here would be 34, 36, 38. So since this comes right here, that equates to 44 wins. When did the greatest decrease in wins occur? Well, let's look. It looks like the greatest decrease occurred from this year to this year. Decrease is a drop where these points go down, and it happened right here from 2012 to 2013. All right, the graph below shows the amount of rainfall for 6 months. Here it looks like 65. Again, we have to look at these intervals, right? It's an interval of 10 for this, which means since this is in the middle, this is a interval of 5. So we've got 65 millimeters, 85, so on. What was the greatest amount of rainfall? Greatest is our max point. Here's the rainfall on the vertical. Time is almost always on the x-axis, on the horizontal. And the greatest amount is right here, which is 85 millimeters. Oops, 88, 85. When did the amount have the greatest increase? Meaning from what month to what month did we see the biggest jump? And that means going from a lower value to a higher value. It looks like everything is almost a decrease except for March and April and November and December. But this is a bigger jump than here. So November to December is our greatest increase. All right, this one I'm going to blaze through. Was the least noon temperature for the 5 days. That's the low point now we're looking at. So the low point for all these temperatures looks like it occurs down here, which lines up with, again, this is an interval of 2. This is halfway, so this is an interval of 1. So that means this is 75 degrees, right? And you can make sure that makes sense. 74, 75, 76, 77, 78, yep. And then when did the greatest increase occur? Now this is a little trickier, but I'm guessing it's from here to here. This is going up. This is a decrease, increase, decrease. This is a bigger increase than this. So from Tuesday to Wednesday. All right, probability. So what is probability? Probability is the likelihood of a certain event happening, and it's simply the likelihood of the event that you want to happen over the total outcomes. The event, sometimes I call it ways to win. That's another way I think about it. So 6 marbles are shown. A marble is chosen from the bag at random. What is the probability that it is a gray or black marble? So the way we're winning in this case, we're drawing a gray or black marble. So how many different ways, how many different gray or black marbles are there? That's the ways to win. There's 1, 2, 3. So there's 3 ways or 3 marbles in which if we draw them, we win. Out of total outcomes, well, how many total things can we draw? Well, there are 1, 2, 3, 4, 5, 6 items. Therefore, our probability is 3 out of 6. The last thing is they want it in simplest form. How do we reduce this fraction to simplest form? We see if we can divide the top and bottom by the same number. We can. I can divide the top and bottom by 3. When this reduces to 1 over 2. A spinner with 10 equally sized slices is shown below. The dial is spun and stops on a slice at random. What is the probability that the dial stops on a gray slice? Ooh, these look, there's no gray slices. This looks, oh, I get it. All right, I was like confused. I was like, is the black supposed to be gray or is the white supposed to be gray? All right, I understand. So what is the probability that the dial stops on a gray slice? Well, there are no gray slices unless the color's not coming through or I'm not seeing it clearly. So the probability that it stops on a gray slice is 0. Unless this is a trick question. All right, cool. Last problem. The spinner with 12 equally sized slices is shown below. The dial is spun and stops on a slice at random. What is the probability that the dial stops on a gray slice? So again, number of ways to win, which is the number of gray slices, are 1, 2, 3, 4, 5. Over the total number of slices. How many slices are there? Well, there are 12. Right? We don't count the slices outside of gray for the bottom. It's every slice. Can this be reduced? Can we divide the top and bottom by the same number? No, there are no common factors, so this is our final answer. All right. Converting a decimal to a proper fraction without simplifying. Basic. Here we go. So how do we do this? 0.05. All we got to do is we got to look at place value. And then this becomes super simple. So this first spot is our 10th spot. This next spot is our 100th spot. This next spot is our 1000th spot. Whoops. Okay. So we have our decimal. We have 10th, 100th, and then 1000th. All we got to do is look at where does this decimal stop. It stops in the 100th spot. So all we got to do is take this number, which is 0.5, or that leading 0 is not going to be not necessary in a fraction. We got a 5, and since it's in the 100th spot, we put it over 100. And it's as simple as that. We don't need to simplify. We don't need to do anything. We just got to understand that this 5.05, since it's in the 100th spot, literally represents 5 out of 100. Next, we've got 0.47. Now, we got a 4 in the 10th spot, but does that matter? No. We look at the rightmost digit, which is 7, which is, again, in that 100th spot. So we put this entire 47 over 100, and we're done. Last but not least, 0.2. Now, we don't have a digit here. This stops in the 10th spot. So in this case, we throw that 2 above, not 100, but just a 10. This is 2 out of 10. All right, Venn diagrams. Here we go. All right, so what are Venn diagrams? Venn diagrams are essentially little universes. So this is a universe, and this is a universe. And why are they touching or overlapping? This is where the two universes overlap. So this is the universe of tennis players. This is the universe of softball players. Why is Miguel in this middle zone? This means he's in both zones, which means he plays both tennis and softball. Okay. The rest of these guys, M, L, and P, or Maya. I'll put a Maya. It's different from Miguel. Maya only plays tennis. She's not in the softball zone. She's on the softball universe. Same with Lisa and Pablo. And with these guys, S, E, I'll say Martina, and then Christine and Charlie. These guys are only in the softball universe. They don't live in the tennis universe. Only Miguel is in both universes and plays both sports. Now the question is, how many people play softball? Well, clearly 5, but what about Miguel? Miguel is also in the softball universe, so he's counted in that number, therefore 6 total play softball. How many people play tennis but not softball? 1, 2, 3, but not softball. So there's 4 people that play tennis, but they said specifically just tennis and not softball. Miguel would not be included in this number, therefore we just got 3. And last, how many people play both tennis and softball? To play the 2 sports combined, it's just Miguel. If they say play tennis or softball, it would be everybody. But it's both those. It's just this one person who lives in both universes, which is Miguel. All right, next question. Actually, wait, let's see. All right, I can leave this diagram up here. Now we've got tennis and soccer. Soccer. We got L, L, A, S, A, L, E, P, C, T, I. I don't think the names matter that much. They're not that specific. Just want numbers. How many people play soccer? 1, 2, 3, 4, 5, but also these guys as well. 6, 7, 8, 9. So 9 total play soccer. How many people play soccer but not tennis? 1, 2, 3, 4, 5. Because these guys play soccer, but they also play tennis, so they're not included. We just got 5. How many people play both tennis and soccer? It's everybody in both universes. A, S, A, L. So that is 4. Okay, last but not least, dance and art. We've got, let's erase these guys. D, M, R, R, A, S, Y, A, D, F, C. Okay. How many members does the dance club have? 1, 2, 3, 4, 5. We got to include these guys because they're in the dance club. They're also in the art club, but they're in the dance club, so there's 5 people in the dance club. How many students are members of both the dance club and the art club, meaning both universes? That's 4. And how many students are in the art club but not the dance club? So these guys are in both. We're talking about just these students. 1, 2, 3, 4, 5, 6. All right, cool. Let's keep going. Let me see if there's any questions. Nope. Constructing a two-way frequency table. Each of 78 students in grades 1 through 3 was asked, can you swim? Here are the results. 11 students in first grade, 16 students in second grade, and 17 students in third grade can swim. So what is this table? This table is just a way to organize the data that we're getting from this survey. So let's just put it down as we read it. 11 students in first grade can swim, okay? These are all people that can swim. So 11 students in first grade, 16 students in second grade, and 17 students in third grade can swim. What about here? Now this is the people that cannot swim. 7 students in first grade, 12 students in second grade, and 15 students in third grade cannot swim. And that's it. All right, this next one. So now let's see. Each of 76 moviegoers was asked, what is your favorite movie type? Here are the results. 4 women and 6 men chose action. 4 women and 6 men chose action. 8 women and 7 men. 8 women and 7 men chose drama. 11 women and 12 men chose animated. And 15 women and 13 men chose comedy. Last but not least, among the dog owners, 5. So here are my dog owners, here are my cat owners, right? So among the dog owners, we're talking about this column. 5 chose wet food and 8 chose dry food. Now my cat owners, 10 chose wet food and 15 chose dry food. Okay, finding opposites of integers. All right, simplify your answers as much as possible. When we're talking about opposites, we're just talking about multiplying by -1. If an answer is positive, its opposite is negative. If the number is negative, its opposite is the positive version of that number. If it's 0, it's just 0. So the opposite of -9 is simply +9. The opposite of 3 is -3. The opposite of -4 is just the number itself. That's like multiplying by -1, then multiplying by -1 again. The opposite of the opposite is just the number itself, which is -4. The opposite of -6 is +6. Opposite of 0, that's just 0. And the opposite of 8 is 8. Last but not least, the opposite of 4 is -4. The opposite of 0 is 0. The opposite of -7 is -7. It's starting to slow down, so we're going to log out soon and log back in. Introduction to solving an equation with variables on the same side. So how do we solve this? The first thing we have to do when we have multiple instances of a variable is we have to consolidate the variables. We have to bring them together. So how do we do that? Well, these are called like terms because they both have an x, which is really helpful. So how do we combine these? Well, it's just like if I told you what's 3 apples plus 4 apples? It's 5 apples. This is the same as saying we've got 3 x's plus 4 x's. When we add them together, what do we have? We have 7x. So that's the first step, is we consolidate these variables. Then we isolate. Now we've got one x next to a 7. And we need to get rid of that 7. Well, what's the 7 doing to the x? Multiplying. The opposite or inverse of that is dividing by 7. Divide both sides by 7. This turns into 1x. Which is just x equals 21 divided by 7, which is 3. All right, next. 13u minus 5u equals 72. Same thing. First, we got to consolidate. What's 13u minus 5u? It's like 13 apples minus 5 apples, which is 8. 8u equals 72. Now, same thing. The 8 is multiplying the u, so we need to divide both sides by 8 to isolate. U equals 72 divided by 8, which is 9. Last but not least, 35 equals 4u plus 3u. Let's add these guys together, and we get 7u equals 35. Multiplying by 7, so we divide both sides by 7, and we get u equals 35 divided by 7 is 5. Classifying solids. Okay. So which figure shows a triangular prism? So what is a triangular prism? A triangular prism is essentially where you take a triangle like this, and then you kind of extend each one of these vertices back. And then you got another triangle on the other side. Whoops. That is the exact same as the one on the front. And which one is a triangular prism? Just B. A sphere is like a globe, is like a basketball, it's a ball. Which one is a sphere? Just figure C. Which figure shows a square pyramid? A square pyramid has triangular faces, like this guy, but a square base. So figure A is your square pyramid. Next one. Again, figure A is our sphere. Oh, there's no sphere option. Okay, which shows a rectangular pyramid? So this one, I guess, is our rectangular pyramid. We got a rectangular base and the triangular sides on up there, so that's B. Which shows a cylinder. A cylinder is like a can of Coke. It's like a circle extended all the way back, and then another circle on the other end. None of these are cylinder. Which shows a rectangular prism. Rectangular prism is just a box. Fancy word for a box. That's figure C, and that's it. This, of course, is a sphere, and they didn't have that option. Okay, which one shows a cone? A cone is a circle that then extends up to a point. It's kind of like one of those dunce hats, or like literally like a traffic cone that you see outside. So cone is figure A. Doesn't matter that it's just upside down. Shows a triangular pyramid. This is not a triangular pyramid, it's a triangular prism, so there is no triangular pyramid. A triangular pyramid would be like this. It would be a triangle on the bottom, and then they would all go up to one point, like that. And then which figure shows a cube? I think B is a cube. It could be a rectangular prism, but it looks like a cube. It's just, that's a rectangular prism where all the sides are equal squares. So I'm guessing that's a cube. Yeah, cool. All right, we'll do one more and then I'm going to log out, log back in. I'm going to really see how long I can go today, because now that I figured out this workaround, we can go for a while. All right, here are 3 solids. So these are nets of solids. What is a net? A net is basically where, let's say you have a cube. Okay. And a net is really opening up. It's like if you have a box and you're unfolding all the sides. So how many faces of a cube do we have? We have 1, 2, 3, 4, 5, and 6. Like right, the top and bottom, left and right, front and back. So if we were to open it up and spread all these sides out, well, here's the back side. Maybe I'll flip open the top side and put it up here. Maybe I'll open the left and right sides out like this and like this. And then the bottom and the front will roll down here. And this would be the way we represent a cube, as a net of all the 6 different faces, right? So that's what they're doing here. So let's see, for each net below, select the solid above to which it folds. So let's look at this triangular prism. So what they've done is, I'm guessing, you know, right, we have this base, and then we got 4 triangles. So it would make sense that we'd have something like, if we opened up the pyramid from the bottom, it's like we'd have these 4 triangles that would come out, right? And you can kind of see if we folded each one of these triangles up like whoosh, like this, it would come back to form a top-down version of this triangular, of that square pyramid. So I'm going to say that this one is our A. This is a rectangular box. This would be a box, and you can tell because they're not all equal. This looks like a perfect cube. So for our cube, we're going to need something along the lines of this. This is a box, right? This side, it's not going to be as tall as it is wide, and you know it's a rectangle. So this doesn't correspond with anything. There's no boxes here. What about this? This, I think, is our C, and I'm going to show you why. C is basically, it's 1, 2, 3 rectangles. You see this is a rectangle here, that's a rectangle back there, and then this one down here is a rectangle. So you can kind of see, I'll redraw it here. There's one rectangle, it's just slanted. There's the rectangle back here. And then we've got this rectangle up front, and then we have these 2 triangles at the either side. So we should have 2 triangles and 3 rectangles, and that looks like this guy right here. So I'm going to call this C. And what is this? This has got to be our cube. Now this isn't perfect, right? It's not, or not, it is perfect actually, it's fine, it's right, but it's not exactly what I drew. What I drew was like this, but that's all they did was they just extended that last piece down here. It's the same thing. We still fold this up and get a cube. So I'm going to correspond this with B. Make sure we got all these right. Yeah, that's nothing. It's this guy, and this guy. So I think that's correct. All right, let's look at this one. I think you can pretty clearly tell the only one that this net is going to work with is this, where we got a circle and then this weird shape unwrapped. I mean, it may not make total sense, but this has got to be A. Okay, this is our box, and this is a box, right? And you can see that this side is kind of smaller. It makes sense that this would correspond to B. All right, this would correspond to a triangular pyramid, right? A triangular base, which would all go up like this. There is none of that, so this is none. This is actually our cylinder. So why? Because if you look at a cylinder, this may not make sense at first, but we definitely have our two circles at the top and the bottom, right? Where does this rectangle come up? Well, a cylinder, this part going all the way around, like this part, actually, if you unravel it, it unravels into a perfect rectangle. Right? If you think about it, it's like the label of a Coke can. They take a perfect square, rectangle, and they wrap it around the can, and that is the lateral side of a cylinder. So that's why this is a perfect net, or an unraveled part of a representation of a cylinder. This is very, your spatial reasoning skills are very important with these types of problems, to really be able to do that manipulation in your mind. Okay, once again, triangular prism, 3 rectangles and 2 triangles. That's what this guy is, a triangular prism. So that's A. This would be for a cone, but I don't see any cones. This would be for a square pyramid, which we got right there. And this is for a triangular pyramid, which we got right there. Do a little log out and a log back in. All right, continue my path. 173, doing pretty good. 31 topics so far. All right, back at the same one. Volume of a rectangular prism. Look how fast that is. Now, this is really great because all we do to calculate volume is we multiply the length by the width, by the height. So whatever 3 values they give you, just multiply them up. So this becomes 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. So this is 125. And it's always going to, volume's always going to be in units cubed, so centimeters cubed, and done. Next one, same deal. We've got 9 times 3 times 3. 9 times 3 is 27. Times 3 is 81, and it's going to be in yards cubed, but they already got that for you, just like that. And last but not least, 6 by 6 by 6. So this is 6 times 6 times 6. 6 times 6 is 36. Times 6 again is 216. All right, division involving 0. Here's the deal. As a matter of principle, we cannot divide anything by 0. This is a non-real solution. It's not infinity. Sometimes people mistakenly say it's in infinity when we divide by 0. That's not exactly the case, but the idea is we call this undefined. You can't split something up into 0 parts or pieces. So 2 divided by 0 is undefined. Or any number divided by 0, a million divided by 0, even 0 divided by 0 is undefined. But if you divide 0 by something, these all equal 0. This is like saying I have $0 split up between 5 people. How much money does everybody get? They get $0 because I don't have any money. That's what 0 divided by a number is, so it's always 0. But both of these are, this is 2 over 0, which is 2 divided by 0, which is undefined. Same with this. This is 6 divided by 0, which is undefined. Next, we have 0 divided by 3. That's okay. That's 0. We have 0 divided by 4. That's okay. That's 0. And last, we got a number dividing 0, and that's no good. That's undefined. 0 divided by a number. That's cool. That's just 0. Translating this sentence into an equation. All right, 59. So this is, look how I do it, just very step by step. I won't even necessarily read the whole thing first. 59 is always an equal sign. 59 is the difference. Difference is subtraction. The difference of Matt's height and 12, meaning we're subtracting 12 from M. Whatever value is given first, which is in this case Matt's height, we put that value first, and then 12 is second. And that's all we got. So 59 equals M minus 12. The product of 8 and Vidya's height is, so look here, this is where the equal sign is going to come. So first, what is product? Product is multiplication. Product of 8, so we got multiplication. Product of 8 and Vidya's height is equals 144. Just placing it down just like that. And there's our equation. 8 times V is 144. Sum is addition. So we know we've got the sum of 12 and Janelle's savings is, which is equal 67. Now they're not asking us to calculate J, but we very easily could once we have this equation set up. All right, next problem. Writing unit fractions with a common denominator to add or subtract. Let's find 1/2 minus 1/8. 1/8, excuse me. So first of all, we can't evaluate this until we get a common denominator. So what have they done? They've converted the 1/2 to something with a denominator of 8. So let's think, how do you make this denominator 8? You can only use multiplication or division. So they've clearly used multiplication. They've multiplied this by 4. But whatever they do to the denominator, they have to do the same thing to the numerator to keep this balanced. So what's 1 times 4? This is 4. What's 2 times 4, which is 8? So that 1/2 becomes 4 over 8. Okay? So that is what goes over here, 4 over 8 minus 1 over 8. Now when we do fraction subtraction, once we've got the common denominators, we just subtract the numerators and leave the denominators as they are. And we get 3 out of 8. Okay, next. All right, 1/6 plus 1/3. We cannot do this because they have different denominators. So what have they done? They've turned this 1/3 into something over 6. So how do we get the 3 to a 6? We must multiply it by 2. But to be balanced, we have to do the same to the top. And therefore, we have 1/6 plus, this becomes 2 over 6. Same denominator, so we leave the denominator the same, add the numerators, and we get 3 over 6. So let's fill this in. This becomes 2 out of 6. And then we add, and we have 3 over 6. It doesn't say to simplify. This simplifies to 1 over 2. But let me see. It doesn't say to simplify, so I'm going to just go for it and see what it says. Yeah, cool. All right, last but not least, 1 over 4 minus 1 over 12. They've turned this into 12, so they must multiply the top and bottom by 3. And we get 3 over 12 minus 1 over 12, which gives us 2 out of 12. Okay, let's do 137 over 50 as a decimal. How do we convert this to a decimal? So when we're converting to a decimal, let me just read the description of this. Yeah, all right. When we're converting to a decimal, all we got to do is recognize that what a fraction is. A fraction is just a division problem. Convert it to a decimal, carry out the division. So we have 137 divided by 50. Okay. There's other shortcuts that we could use, but let's just do the classic. So 50 goes into 137 two times. 2 times 50 is 100. Subtract 137 minus 100 is 37. Bring down the 0. 50 goes into 300. And so, oh, we forgot to put the decimal on top. Very important. Decimal goes straight up top. 50 goes into 377 times. 7 times 50 is 350. Subtract, we got a 20. Bring down a 0. And 50 goes into 200 4 times. 4 times 50 is 200. And we are done. So the decimal equivalent of this is 2.74. All right, next one. 8 over 25. Now, we could again do the division. We can also, there's another shortcut we can do here where we can get this to 100. It's kind of up to you. If you want to turn this into the denominator into 100, which can sometimes be easy, we could have done it the last time too, is we just multiply this by 4 in this case and do the same to the top, and we get 32 over 100. The reason why this is nice is because now we can be like, well, wait a minute, this is 32 over 100. That's just represented as 32 hundredths, or 0.32. Right? Dividing by 100, we can think about it as moving the decimal twice to the left, which this is. Or we just know that 32 over 100 is 0.32. The other way, again, is we could do division. 25 goes into 80 3 times. 3 times 25 is 75. Bring down the 0. And then 25 goes into 50 twice. So 0.32. All right, cool. And last but not least, 87 over 20. Let's go ahead and do this division. I'm going to add a couple zeros here and make sure to put my decimal right on top. 20 goes into 87 4 times. 4 times 20 is 80. Do the subtraction. Bring down the 0. 20 goes into 70 3 times. 3 times 20 is 60. Now we got 10, and bring down the last 0. 20 goes into 100 5 times. 5 times 20 is 100. And we are done. 4.35. Cool. Let's keep going. Ratios, proportions, and measurement, choosing U.S. customary measurements. So this is all about having a good grasp of what these measurements actually mean. So 1 bucket holds about a pint or a gallon. So if you're familiar with a gallon is like a gallon of milk that you usually buy at the store. So buckets are usually pretty big. A pint is much smaller than a gallon. So the way it works is a gallon can be split up into 4 quarts, and then each quart can be split up into 2 pints. So if we look, if this would be a gallon of milk, first I'd split it up into quarts, right? There'd be 4 quarts in a gallon. And then half of one of these quarts would be a pint. That'd be a really small bucket. So we'd say 1 gallon of water is a bucket. Keith's finger is about how long? Well, feet, yards, and miles is definitely too long. 9 feet is taller than the tallest person, I think. 9 inches. However, 9 inches is not a realistic measurement for somebody's figure. More like 3 or 4 inches. So that's off, but that's going to be our only option. And then a large horse weighs about an ounce. Not an ounce, because an ounce is like 16 ounces equals just 1 pound. So a horse can't weigh 1 ounce. That's tiny. Can't even weigh a pound, because that's way less than us. So it weighs a ton. A ton is 2,000 pounds. All right, let's go to the next one. Shen drank a total of 7 cups or gallons of water. So we're usually supposed to drink about 8 cups of water a day. This is insane to drink 7 gallons. I don't think you would be able to survive that. And there's 16 cups in a gallon, so that's about half of a gallon of water. Then we've got Donna's finger is about 3 inches long. That makes sense. And a metal fork weighs about 2. Now let's look at this. Tons, definitely not. It's either pounds or ounces. You might be tempted to think pounds, but pounds would still be pretty heavy for a fork. I'm gonna say 2 ounces. I think that should be that should be good. That even seems light for a fork, but it's somewhere in the middle there. Okay. Last but not least, Ahmed's house is 15 what from school? Inches. That doesn't make a lot of sense. Feet. I mean, feet and yards, that's super close, right? Like 15 feet. He literally lived right next door. 15 yards. Yards is just 3 feet, so that's like 15 yards would be 45 feet. He could, but I'd say a more reasonable thing is 15 miles from school. Milan drank about 2 gallons. That's a lot. Just for lunch, we'd say probably maybe 2 cups. That makes sense. And Lashonda's bowling ball weighs about 3 ounces, pounds, or tons. 3 tons would be 6,000 pounds, which doesn't make sense. 3 ounces is really, really small, but usually we'd say maybe like 3 pounds. That sounds about right. Okay. Find the distance between point G and H. So now we're finding distance between points, I think, that share a common coordinate. So it basically means points that are either straight across from each other or right on top of each other. How do we figure this out? Well, this is actually not too bad. All we got to do is literally count the number of grid spots over to the right. One is from the next. So if we look at J and I, we're just going 1, 2, 3, 4 across, and that's the distance. Super straightforward. Now, if we look at these guys, they're right on top of each other. We now just count the distance going up or down. It doesn't matter which way we go. Remember, distance is that absolute value, so it's not going to be negative. So we go down 1, 2, 3, 4, 5, 6, 7, 8. The other way to do it is to look at the y coordinate up here, which is 3. This one is -5. And it's just the difference of 3 minus -5. Remember, minus and negative becomes a positive. 3 plus 5 is 8. So that's the other way to knock this out. All right, and then last but not least, C and D we can count as 1, 2, 3, 4. You could also do 2 minus -2, which is also 4. All right, finding outputs of a one-step function that models a real-world situation, 2-variable equation. All right, a construction crew is lengthening a road that originally measured 50 miles. The crew is adding 1 mile to the road each day. So it originally measured 50 miles. Crew is adding 1 mile to the road each day. The length L in miles after D days of construction is given by the following equation. Oh, so they actually did it for us. What is the length of the road after 31 days? Remember, D represents days. So if we want to find where it is after 31 days, we just replace or plug in 31 for D. So now we'll rewrite this equation as L equals 50 plus 31. And then we carry out this addition. 50 plus 31 is 81. So it is simply 81 miles. Let's do the next one. So an amusement park charges an admission fee of $20 per person. Again, they're putting this in nicely first. The cost in dollars of admission for a group of people is given by the following. So it's literally like if P equals 1, it's going to be 20 bucks. If P is 2, it's going to be 40 bucks, etc. What is the cost of admission for a group of 4 people? Remember, P represents the number of people going. So we're just going to replace that P value with 4. I put parentheses in to show that this is a multiplication. That's not 20 and then P is like the third digit. That's 20 times P. So 20 times 4, which is $80. Okay. Last one. A plant is already 25 centimeters tall and it will grow 1 centimeter every month. The plant's height H in centimeters after M months is given by the following. H equals 25 plus m. What is the plant's height after 21 months? Again, m represents months, so we're plugging in 21 for m. H equals 25 plus 21. 25 plus 21 is 46. 46 centimeters. Factors, write all the factors of 33. So we're now figuring out factors of a larger number. So what is a factor? Factors are all the different numbers that can be divided cleanly into this number 27 without a remainder. So how do we figure out all the factors? So first, we'll always start with the number and 1, because 1 times 27, we're going to do it in factor pairs. 1 times 27 is 27. Now let's think about numbers in between. I also know that 3 can go into 27, and 3 times what is 27? 3 times 9 is 27. And this is it. These are the only factors of 27. So we got 1, 27, 3, and 9. And order doesn't matter, I think, for these entries. Okay. What are the factors of 16? Well, again, we got 1 and 16. It's divisible by 2, so we can also have 2. 2 times what is 16? That's 8. Then we have one more factor. We also have 4, because 4 times 4 is 16. Do we need to write another 4? No. So in this case, we've got 1, we've got 16, we've got 2, we've got 8, and we got 4. All right, last one. Write all the factors of 12. So start again with 1 and 12. This is even, so we know 2 goes into it, 2 goes into it. How many times? 6 times. And we got one set in between, which is 3 times 4, which is 12. And those are all the factors. So we got 1, 12, 2, 6, 3, and 4. Next one, creating triangles from given side lengths. In each figure below, the segments on the sides can be moved. Create the following triangles if possible. All right, the first given side lengths. Let me see this whole thing. Yeah, probably okay. A triangle with side lengths of 4, 7, and 9. I know what they're testing here, and what they're testing is this basic rule where if we have 3 side lengths, the rule is this: we can never have one side length that is smaller than the difference of 2 of the other side lengths. Okay, so what does that mean? So one example of that is if I had a triangle that had a side length of 9, a side length of 7, and a side length of 1. This cannot exist because 1 is smaller than the difference of these 2. Now, yes, 7 is also smaller than the difference of 9 and 1. 9 is not smaller than the difference of 7 and 1, but we just need to find one instance where we have that violation and the triangle can't exist. The other rule is, let's say I have 3, 5, and 12. The other rule, which is kind of the same, is one side cannot be more than the sum of the other 2 sides. So 3 plus 5 is 8. This is bigger than 8. This triangle cannot exist. So I can already tell you 4, 7, and 9 is going to exist, but this is going to be a visual way to do it. So what we're going to show is if we kind of reach these together, we're going to be able to form a nice triangle like this. All right. So now we've created a triangle there, and that's cool. This one, again, it doesn't violate the rule, right? 4 minus 3 is 1. This is bigger than that difference. There's no combination where that will be a problem. Hey, we can make a triangle. Cool. I think that's all you have to do. All right, cool. So let's do the same thing here. This is not going to work, right? Because 9 minus 6 is 3. 3 is greater than 2. But you can try and see this will never reach, right? That's what that theorem shows, that we'll never be able to do this, so no triangle possible. Same thing here. 7 minus 3 is 4. That's greater than 3. No triangle possible. They don't reach. Last one. This will definitely work. And then this guy will not work, right? 2 and 3, they will never touch. So no triangle. Oof. Oh. Okay. Find the area of the figure sides meet at right angles. So how do we find the area of one of these piecewise rectangles? All right, so these are pretty fun once you get the idea of it, once you get the concept. So let's recreate this. You know what I'm going to do? Uh-oh, what did I do? Hold on. Put this over here. I think this should work. Okay, cool. All right, so what we got to do is we need to break this up into 2 rectangles because we know how to calculate the area of a rectangle. We don't know how to do it for this crazy thing. So what we're going to do is I'm going to draw a little line across and split it up. Now I got 2 rectangles. I got this rectangle and I got this rectangle. So what are the dimensions of this rectangle? This top piece is 1 and this other side is 4. But you might look at this and be like, well, what about the 6? The 6 doesn't correspond to this length. The 6 corresponds to this all the way down. So it's a 1 by 4 rectangle. To get the area, we multiply 1 by 4. Those 2 dimensions gives us an area of 4. What about the area of this guy? Well, this length all the way across, it's not 4. 4 is just from here to here. All the way across for this entire rectangle is 5. All the way up and down is 2, right? 2 and 2 over here. 5 times 2 gives us 10. Now we got the individual areas and we add them. 10 plus 4 is 14. Okay, next. I'm going to show you a different way to solve this one. And the last way we kind of broke it up and used addition. This one I'm going to show you how you can use subtraction. Both will work. Doesn't matter however you want to set it up. I'm going to go like this. I'm going to say this could have been one giant rectangle. And if this had been one giant rectangle, what would have been the area of this entire rectangle, this entire thing? Well, the height is 3. And the width is, or the length or whatever, is 6. 6 times 3 gives us a total area of 18. But then we've cut out this little rectangle. So we need to calculate the area of this little rectangle that we've cut out. It's 3 by 1. So therefore the area of this little rectangle is 3 times 1, which is 3 meters squared. So we're removing this, which means subtraction. So we're taking 18, we're subtracting 3, and we're getting 15. Now again, with this one, I can do the addition method or subtraction method. I'm going to do addition, but I'll show you. If I wanted to do the subtraction, all I would do is I would extend this out, and be like, okay, we have one giant rectangle. I'm subtracting this piece and this piece. Could do that, but instead, I'm just going to cut these into 2 rectangles and compute them separately and then add them. This one is 2 by 6. Which means 2 times 6, which is 12. This one is 2 by 2. 2 across and 2 down. 2 times 2 is 4. So we got 12 and we got 4. We add them up and we get 16. All right, cool. Here we go. Identifying horizontal and vertical cross sections. In each figure below, a plane passes through a geometric solid as shown. Choose the shape of the cross section formed. So let's see. We've got a, oops. We've got a square pyramid is what this looks like. And we've got a cross section going across. So what would that cross section be? Well, it's a perfect, it's going to come right up here. And that's also going to cut out a perfect square. Okay, again, spatial reasoning. You just got to sort of see, imagine what's going to happen if you sliced it. Now, what about this? This is going to be really interesting. This may be very counterintuitive, but if we have a cone, okay, and we cut it straight across like this, what are we going to get? We're actually going to get just a triangle. And what about down here? Of course, we got a rectangular prism. We get a cross section, a slice, and that's going to be a perfect rectangle. Oh, did I not do one correctly? Hold on. Triangle. Hold on, which one did I do wrong? This one, this one. Oh, that's not a square prism. That's not a pyramid. I didn't look at that correctly. That is a triangular. That's a triangular pyramid, I think, right? So it goes like this. So you'd basically get an impression of what's right on the bottom. So you get another triangle here. So we get a triangle. Okay, my mistake. I drew the wrong figure when I put it down here. Let's do the next one. So up top, again, this is a triangular prism, and now they're doing a cross section across here. So we're going to have this side here. We're going to have this side coming down. We're going to have this coming across. So this will be a triangle again. Right? This is going to come across a sphere. It's just like if we cut the globe in half and looked, or cut an orange in half and then looked, and what would we see if we look at it flat on? That would be just a circle. And here, it looks like you might get a triangle, but you're just getting a cross section. You're cutting it straight off, and then you're looking at that flat surface, and that would be a rectangle. I think that's right. Okay, last one. All right, here we go. We got a cross section across. What's going to come out? We cut this off, and we're going to get a perfect rectangle right there. This one is going to be a triangle. So again, if we have our cylinder, these two sides are going to form the triangle. This is going to come across like this, and we're going to get just that nice triangle there. And last but not least, a cylinder, just like cutting a can of Coke straight in half and then looking at that shape, and that's going to be a perfect circle. Okay, let me just check something before I keep going. All right. I'm going to knock out a couple more topics, and then I might take a break here. Okay. A certain store sells t-shirts in 6 colors. The number of t-shirts sold in each color last month was shown. Oh, let's actually start. This is just the explanation. Interpreting a bar graph. So a shop repairs 5 types of electronic devices. The number of repairs of each device last week is shown in the bar graph below. Use this bar graph to answer the questions. Okay. Which device was repaired the least often? So number of repairs on the vertical axis, which means we'd want the shortest one of these guys. So it's not radio, it's not these guys, it's CD player. So CD player was only repaired 3 times. Is that what it looks like? And that's the number of repairs. How many more repairs were made on televisions than radios? Televisions looks like we're at 9 repairs. Radios were at 6. So how many more? That's the difference between 9 and 6, which is 3. And how many devices had fewer than 9 repairs? Well, everything that's going to be below this mark. Computer. It does not fall in that category. Television, I don't think it falls in that category because it's at 9. So we don't count this. Anything below 9. So we got radio, telephone, CD player. So that's 3. A local real estate company has 6 real estate agents. The number of houses that each agent sold last year is shown in the bar graph below. Use this graph to answer the questions. Which agent sold the most houses? So whoever's at the highest point, which is Eric. And Eric sold 9. How many more houses did Rita sell than Isabel? So Rita's at 7. Isabel is at 5, so she sold 2 more. And then how many agents sold at most 6 houses? At most 6 houses. Which means if they sold 6 houses, they also fall into this. And at most doesn't mean more than, that means less than or equal to. Because like I have at most $100, I could have 98, 97, 50, whatever. So we've got 1, 2, 3. These guys sold above, so they don't count, so only 3. Okay, last but not least, let's do one more, and then I'm going to take a break for now. A local school has 6 clubs. The number of students in each club is shown in the bar graph below. Use this bar graph to answer the questions. Which club has the fewest students? Drama, clearly. And how many students they have is 2, right? How many more students are in the math club than the drama club? Math club, we have 9 students. Drama club, we have 2, so the difference of 9 and 2 is 7. And how many clubs have more than 9 students? So here's our cutoff. Not this guy, this has exactly 9. So we got chess and debate, so just 2 clubs. That's it. All right. So we're going to pause right there, and let's see how many times. Look at that. That was great. I got a lot done today. I think I got 40 some topics done. So we're already up to 30%, which is sweet. Now I figured out how to get around that little glitch of the whole thing slowing down. So I just log out, log back in. So this is awesome news. That was super fun. Got to jump off and do some private tutoring sessions. But thank you guys for joining, and make sure to subscribe if you want to see more math problems being solved, especially if you want to see SAT Khan Academy problems being solved. And I'm going to make it through all of these ALEKS problems one way or another eventually, and then make sure to look for the channel. Look on the channel for the individual videos all chopped up and edited with music and all that. Thank you guys so much for joining, and I'll see you guys next time. Take it easy.